Hello everyone. We from Global Teachers have bought a very good chapter from class 10 for you people. And as you know, metals and non-metals is a very important chapter if your class 10 syllabus is considered. So we'll be doing half of the chapter today, and later on in another class we'll be doing the rest of the chapter. So let's start with it. So as we know, like metals and non-metals constitute a very important part in our syllabus. So before starting with metals and non-metals, we must have a basic idea about the periodic table, what a periodic table is and where the metals and non-metals have been placed in the periodic table. The rest of the history of the periodic table we have already covered in periodic properties. From here I'll just give you a brief idea about the placement of these elements in the periodic table. Then we further go on classifying them into metals, non-metals and metalloids. So let's start with the chapter. So first of all, this is the periodic table that has been accepted, and this is known as the modern periodic table. Till now, this is the most accepted form among all the periodic tables that have been discovered over the time. This periodic table has 118 elements in total, out of which 94 are naturally occurring and rest 24 have been synthesized by men. So there are 118 elements in total, out of which 94 have been discovered and they exist as they are existing naturally, and these 24 are synthesized by human. Okay, so whatever we come across around us, either it's air or any material, they are made up of some elements in the form of compounds or molecules. So these elements forms the basis of all the material which is around us. So be it air, be it water, be it fire and earth, everything is made up of the elements which have been shown in the periodic table. So what does the periodic table tells us? Basically, with the help of periodic table, we are able to identify the placement of different elements according to their different properties. It is basically a classification of elements on the basis of their properties. The elements which are showing similar properties have been classified together in different rows and columns, which are known as groups and periods respectively, and which do not show same properties. They have been kept in different groups and columns. Okay, so with the help of periodic table, we are able to distinguish different positions of elements. Next, we basically classify all the elements of the periodic table into three categories, namely non-metals, metals and metalloids. All these three categories have been shown into different colors. I have not mentioned the names of the elements, but just to give you a brief idea, like where the placement of these three categories is there on the periodic table, this has been shown with this color scheme. Like non-metals आपके ये, and this whole green वाला part is your non-metallic part. This blue color shows all the metals. These are metals, and this zigzag portion, this is metalloid. I'll further be explaining what does this term metalloid means. Till now, you have a clear idea that all the elements are classified into three categories, namely non-metals, metals and metalloids. So आपको यहीं से देख के बहुत क्लियर आइडिया हो गया होगा कि ओवरऑल जितने भी एलिमेंट्स हैं, majority fraction of elements is metals. As you can see in this schematic periodic table that most of the periodic table is blue in color. That means most of the elements are metallic. Let's move further. Yes. So you can see here that I have classified this periodic table into horizontal rows. So these horizontal rows, these are known as periods. And in the modern form of periodic table, we have 7 such periods. You can count it here. These lanthanides and actinoids are kept differently. I'll tell you the reason later on. What does this classification into periods signify? As in, all the elements in a particular period show specific similarities, which we'll be discussing further. What similarities are there in the period elements taking place in same period. So, whatever elements are placed in these horizontal rows, they are periods, and these elements have some similar properties on the basis of which they have been classified in the same rows. Okay, let's move next. There is another one classification which have been done vertically. We can either call it families, but according to the modern periodic table, these vertical columns are known as groups. So starting from 1 till here, we have total 18 groups in the modern form of the periodic table. And again, the elements are classified into different vertical columns on the basis of their similar properties. All the elements which exist in a column, in a vertical column, they have specific properties which are same for all the elements. So again, these properties will be discussed further, and this classification is purely on the basis of their similarity, because periodic table, what does it give us? Yes, it gives us a classification of different elements on the basis of different properties. So whatever classification we'll be doing here, be it in periods, be it in groups, it is clearly on the basis of similarities between different elements taking place, like finding a position in the same group or in the period. So in total we have 18 periods. We start counting from here. We will have 18 total groups, and we have total 7 periods in the periodic table. Let's move further now. Yes, this is the form of, this is a typical modern periodic table that we have today. Here we have, these are known metals. Remember that I showed you in the previous diagram. All these are, this whole section is metals. If we keep this zigzag portion apart, this whole thing is known metals. These are metals. Okay. Now, this diagram shows us, as you can all see here, we have a schematic periodic table in front of us. So, whatever elements are there in the left side of this zigzag line, this solid zigzag line, they are basically metals. This whole portion is metals. Okay, they all are metals. Whatever elements are present on the left side of this zigzag line, this black zigzag line, they are metals, and the elements which are present in the portion, this zigzag portion, they are metalloids. And the elements on the right side of this, they all are non-metals. Correct? So one more important thing, that all the metals, the elements which are present in the left hand side of this zigzag line, most of them are solid at room temperature. Room temperature is generally considered around 25 degrees Celsius. So most of the metals or the elements which are present on the left hand side of the zigzag line, they are metals, and they are solid at room temperature. There are certain exceptions, we can consider mercury, Hg, which is liquid at room temperature, like the mercury they use in thermometers. So it is liquid at room temperature. We can consider cesium and gallium as well. Like they are not liquid at room temperature, but if we keep them on our palm, so they melt with the heat of our body. Okay. So they also have very less melting point. Okay, let's move next. So these are the properties. Like now we'll be discussing about the properties of metals. Specifically, we'll be discussing about the properties of metals. So all the metals, whatever metal we talk about, be it iron, be it silver, be it gold, aluminium, whatever metal we can think of, all the metals have a luster. Luster means they have their own shine. Okay, so all the metals they have their own shine, and this property is known as luster, or we can simply say that metals are lustrous. Here you can see this is cesium, and this is like a picture of graph. Still you can see that there is certain shine which is coming out of this metal. That means metals do have their own shine. Next we have the second property, which is known as ductility. What do we mean by ductility? Being ductile means that whatever substance is ductile, it can be drawn into thin wires. So the property of any matter, by this it can be drawn into very thin wires, that property is known as ductility, and that particular substance is known as ductile. So all the metals that we have, they generally show the property of ductility. That means they can be drawn into very thin wires. Like you must have seen the wires inside the electrical wire. You will see very, very thin wires of copper or aluminium. So this is because of this property of ductility. Next we have third property, which is malleability, and the elements which show the property of malleability are known as malleable. So with the help of this property, these metals can be drawn into very thin sheets. Like if I talk about aluminium, you must have seen aluminium foil at your home, in which we wrap up our dust, and this same aluminium is used for the construction of used aeroplanes. So how, like, we can easily clear that aluminium foil with our hands, but you can easily have an idea about the hardness of a plate. So it is because of the property of malleability, these metals can be converted into very thin sheets, and this property is known as malleability. So metals are lustrous, they are ductile, they are malleable. Now let's discuss some other properties. Now, next property is density. All the metals that we see around us, they are dense, and because of their density, they have high melting point. Except as I just told you, mercury, cesium, and gallium, they have like low melting points. Generally, all the metals have high melting points, and they are very dense. What is density? Mass upon volume ratio. So they have great density. Next is conducting nature. So they are very good conductors of electricity and heat. Like all the wires that we see in our home, they are made of metals. Like outside coating is of the pieces of plastic or PVC. Just to avoid the shock that we can get if we directly get to touch the metal. Rest, they are like the conductivity, whatever is happening inside the wire, it is because of the metal. Okay, so they are very good conductor of electricity. And how they are good conductor of heat? Because like we use utensils that are made up of metal for cooking. Like we keep them on the gas stove and the food gets cooked inside it. We never keep plastic utensils over the gas stove to cook our food. Because they are not good conductors of heat. Metals are. That is why they are used for cooking. Okay, let's move next. Now let's talk about the reactivity. If we talk about the valency of elements or metals specifically, they generally have 3 or less than 3 electrons in the outermost shell. Like if we talk about lithium, the atomic number is 3. So if we talk about this electronic configuration, it will be 2, 1. That means it has 1 electron in the outermost shell. Again, if I talk about magnesium, magnesium has atomic number 12. Its electronic configuration is going to be 2, 8 and 2. So again, it has 2 electrons in the outermost shell. So whatever metal you want to take, you can consider any metal. If you write its electronic configuration, it will have either 3 or less than 3 electrons in the outermost shell, or we can say all the metals have 3 or less than 3 valence electrons. Okay, let's move further. So this is basically a summary of all the properties that we have discussed till now. All metals are solid except mercury. They are hard except sodium and potassium. Sodium and potassium, they can be cut with knife, but we cannot cut iron piece with knife, right? So they are so soft that they can be cut through a knife. They have luster, yes, they have their shine. They have high melting and boiling points, yes, we discussed it. They are ductile, that means they can be drawn into very thin wires. They are very good conductors of heat and electricity. Other than this, definitely they are malleable. This is one more property, that they are sonorous. Sonorous is something which can make sound. So if you will collide two metals, so they'll make some sound. If anything metallic gets dropped from your hand and it strikes the surface, so it makes certain sound. So all the metals which, when they collide with each other or with any other substance, they make certain sound, and this property is known as sonorousness of the metals. Let's move next. Now we'll be discussing certain properties of non-metals. So non-metals, as I told you, they are present on the rightmost side of the periodic table. So certain example, that is sulfur, nitrogen, selenium, bromine, iodine, chlorine, fluorine, oxygen, they all are carbon. They all are non-metals. Let's discuss about the specific properties. So this is the placement of all the non-metals. We have discussed it. They are present on the rightmost side of the periodic table. Mostly they are gases. So as we have already discussed that all the non-metals are present on the rightmost side of the periodic table, and they are mostly gases at room temperature. All the non-metals, be it carbon, nitrogen, oxygen, fluorine, neon, whatever non-metal we take, they are gases at room temperature except bromine. Bromine is a non-metal which is liquid at room temperature. Rest all the non-metals are gases. Let's move next. So if we talk about the properties of non-metals, they are dull. They do not have any luster. They do not shine. Like our atmosphere is completely gases. It has all the non-metals inside it, but we cannot see any shine coming out from the air. That is because they are dull, or any non-metal, they do not have their own luster. They are brittle, like they can be broken with some force. So far हम लोगों ने डिस्कस कर लिया है the placement of different metals, non-metals and metalloids in the periodic table, and we have also discussed properties of all the metals. Rest properties of non-metals और what are non-metals and metalloids क्या होते हैं, इसको हम next video में discuss करेंगे. उसके अलावा we'll be doing some questions also on the basis of whatever we'll be discussing by that time. So for that, stay tuned for the next video. Thank you.